All right, welcome to the week of April 27th. We are still on quadratics this week. Last week we spent the week on factoring and solving for x, which will apply to other subjects beyond quadratics. You will use solving for x throughout your whole math career and every math class you're going to take through high school and most likely in college. So that's why I spent a whole week on it. Factoring is important, solving as a tool to solve for x. Now, as far as a quadratic is concerned, you factor to find the x-intercepts to solve for x. Solving for x when it comes to a quadratic equation means finding the x-intercepts. So factoring works really well when the problem factors nicely. If the problem doesn't factor nicely, meaning there's not two whole numbers that multiply to give c and add to give b, then you have to use the quadratic formula, which I showed you a couple weeks ago, and we're going to spend this week practicing on that because we just kind of went through that real fast. I thought you guys already knew that, but I don't think you did. So I want to spend some more time on it. So here's an example of a problem that the quadratic formula has already been done. Inside the square root symbol is b squared minus 4ac, and I've already done that work for you. And this is what I ended up with. Now this is not simplified. You can reduce this fraction. All right, and this is usually the hardest part when it comes to these types of problems, especially if you're not allowed to put your answer in decimal form. If they want it with a square root symbol in your answer, then you have to be able to factor this down. You have to, well, not really factor it, but reduce it down. You have to be able to reduce this fraction. So here's a common mistake. People want to reduce 4 and 10 and say this is 4 plus or minus the square root of 48 over 5. All right, that's one answer that's pretty common to a problem like this. And here's another one. You want to reduce all three of these numbers, the 8, the 48, and the 10, and you get 4 plus or minus the square root of 24 over 5. All right, these are two common mistakes. These are both wrong. All right, the first one, you realized that you can't reduce a whole number with a number inside of a square root symbol. So you reduced 8 and 10 to 4 over 5. 8 over 10 reduces to 4/5 because 2 goes into both those numbers. But you did not reduce the square root of 48. So that is correct. You can't reduce the square root of 48 with a whole number. So this is almost right. The problem with this is that there's a whole number in front of 48, and in this case it's a 1. So whatever you reduce 8 and 10 with, you have to reduce the 1 as well. Well, 2 does not go into 1 evenly. So you can't reduce 8 over 10 because you're not reducing the 1. You have to reduce all three whole numbers to be able to reduce the fraction. And you can't do that here, so you can't reduce just the 8 and the 10 and not the 1. Technically, you could split 1 in half and say this is 0.5 times the square root of 48, but you're not going to see that happen. You don't reduce down to decimals. That's not really making the problem any cleaner. You only reduce fractions if you can reduce them to whole numbers. So don't do this because you did not reduce the 1. Now, I kind of already explained why this one is wrong. You can't reduce a whole number with a number inside of a square root symbol. So even though 48 is divisible by 2, you can't reduce it because it's not 48, it's the square root of 48. So you can't do this either. So if neither one of those work, but I'm telling you this does reduce, there's got to be another way. And the way is to break down the square root of 48. So you do a prime factor tree. So I'm going to start you off with the square root of 48, and I'm going to reduce the square root of 48 for you. So you got to think of what is the prime factorization of 48? What are all the prime numbers that multiply to give 48? Well, it's 2 and 24 multiply to give 48. So, but in this case, they're square roots. So the square root of 2 times the square root of 24. Well, 24 breaks down into the square root of 2 times the square root of 12. 12 breaks down to 2 and 6. And 6 breaks down into 2 and 3. So that would be your prime factorization. 1, 2, 3, 4 2's and a 3. So basically the square root of 48 is equal to the square root of 2 times 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 the square root of 3. If you multiply those 5 numbers together, you're going to get 48, since they're all inside of a square root. So is your answer. 2 times 2 times 2 times 2 is 16, times 3 is 48. Now, how does that help? Well, think of this. Think if you had the square root of 9 times the square root of 9. Square root of 9 times the square root of 9 is 3 times 3, which is equal to 9. So whenever you're multiplying two numbers together that are inside of a square root and they're the exact same number, you just get that number. Here's another way to look at it. If you're multiplying two numbers together that are inside of a square root, they're the exact same thing. Whenever you're multiplying the same exact thing together twice, you're squaring it. So you're basically squaring the square root of 9. It looks like that. Square root of 9 times square root of 9 is square root of 9 squared. And when you square a square root, the exponent and the square root symbol cancel each other out, and you're just left with 9. So there's two different ways to look at it. The point I'm trying to make is it doesn't matter what that number is. It could be 1,034,000,034. As long as it's the same number, that's going to be your answer. Whatever number is inside the square root symbol when you're squaring it is your answer. So back to the problem. We have 4 square roots of 2. So 2 of them, the square root of 2 times the square root of 2, that's the whole number 2. Another 2, square root of 2 times the square root of 2, that's another whole number 2. And square root of 3, there's nothing to combine with it. So that stays square root of 3. So now we have the whole number 2 times the whole number 2 times the square root of 3. And 2 times 2 is 4. So we have 4 times the square root of 3, which we just write 4 square root of 3. We don't write the multiplication symbol in between them. So the square root of 48 breaks down into 4 square root 3. Now, going back to our original problem, we have 8 plus or minus 4 square root 3 over 10. Now we can reduce that fraction because we have 3 whole numbers, 8, 4, and 10, that all reduce by the same number. 2. 2 goes into all 3 of those numbers. So we end up with 4 plus or minus 2 square root 3 over 5. That's how that breaks down. It's not either of these, it's that in the corner. Inside the box in the corner is the correct answer for that, because square root of 48 is 4 square root 3. Now let me show you another way that's a little bit quicker to break down the square root of 48. You can look for a perfect square that is a factor of the number you're trying to break down. So you're trying to break down the square root of 48. What do I mean by a perfect square? I mean 4, 9, 16, 25, 36, 49, etc., etc. The reason I wrote them in a diagonal line is because if you look at any times table, the diagonal from the left-hand corner down to the bottom right-hand corner are the perfect squares. It's 4, 9, 16, 25, and so on and so forth. So do one of these perfect squares go into 48 evenly? Yes, 4 does, but there's a bigger one that does. 16. 16 goes into there 3 times. So the square root of 48 can break down into the square root of 16 times the square root of 3. That could have been the first two numbers you used. Last time I used 2 and 24 because it's an even number, so it's easy to see that you can divide it by 2. But if you're looking for the biggest square root or perfect square that goes into there, it's 16. So the square root of 16 times the square root of 3, and the square root of 16 is a perfect square. Square root of 16 is 4. So the square root of 16 is actually the whole number 4, and the square root of 3 is just the square root of 3. So boom, there's your answer, 4 square root of 3. Some people think this is easier because it's less work, it's quicker. Some people think it's more difficult because you got to think in the beginning, all right, what's the biggest perfect square that goes into 48? And some numbers are a little bit harder to figure out. So it doesn't matter which way you do it. You can break it down into 4 2s and a 3 and get 4 square root of 3. Or you can break it down into 16 and 3 and get 4 square root of 3. There's no right or wrong way to do that. It's personal preference. But the main thing is you need to end up with 4 square root of 3. All right. That's all we're going to do for today is we're going to break down numbers. Every problem in your work today is just a number inside of a square root. So we're not going to have to use the quadratic formula yet today or tomorrow. We're just going to practice on reducing radicals. This symbol right here is always called a square root. It's actually called a radical because if you have this, the cube root of 64, now it's a cube root. You don't really call it a square root. So just that symbol in general that looks like a division sign is called a radical. So we're going to reduce radicals for your work today. So it's going to be just like the square root of 48 example, but it'll be other numbers besides 48. They may even have 48 in there, but I doubt it. So let me do one more example for you. Say it is the square root of 80. How would you break down the square root of 80? Well, you could do the 2 thing again. You could keep breaking it down into 2s. 2 and 40, 2 and 20, 2 and 10, 2 and 5. All right, so I picked one that's similar to the last one. You got 4 2s and a 5. That means 2 times 2 times 2 times 2 times 5 is the prime factorization of 80. You broke 80 all the way down into prime numbers that when you multiply those prime numbers together, you get back to 80. 16 times 5 is 80. So you got 2 square root of 2. Square root of 2 times square root of 2 is the whole number 2. Square root of 2 times the square root of 2 again, that's another whole number 2, and the square root of 5 is all by itself. So you end up with 2 times 2, which is 4, times the square root of 5. 4 square root 5. So again, what's the biggest perfect square that goes into 80? 16, 5 times. So you could have done it a little bit quicker and said the square root of 80 is 16 times 5. And the square root of 16 is 4. So you end up with 4 square root 5. So either way is fine. And you don't even have to start with 240. You could have started with 810. If you start with 810, 8 and 10, you'll still end up with the same answer. 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2. 10 breaks down into 2 times 5. So I've got 1, 2, 3, 4 2s and a 5. 4 2s and a 5. So it doesn't matter what your first 2 numbers are. If you're going all the way down to the prime factorization, you're going to end up with 4 2s and a 5. If you're looking for the shortest way to do it, the first 2 that you do matter. You want to pick the one that's the biggest perfect square that's a factor of 80. So that's your work for today. Tomorrow will be pretty similar. We'll make it a little bit more complicated, and then we'll start getting into quadratics.